Welcome to this presentation on basic AI. Now, I was asked to provide a presentation designed to quickly bring you up to speed in a couple of days on AI systems, and that's what we're going to do within this boot camp. Now, this boot camp is a prerequisite to my other presentation, or the deeper presentation on moving towards superintelligent in the lab, or what we call the dev presentation. If you're attending that session, I will go much deeper into what is being designed in advanced AI labs around the world and what we can expect in this decade and beyond. I will go fast, but the valuable content is on the screen, and you all have a copy of the deck, while the rest is just me rambling on so you can take some notes. We have lots to cover over 2 days, including hands-on labs where you're going to do some coding. So let's get going, and we will have a full panel Q&A at the end for any questions. So we're just going to power through this, keep your questions, and then we'll have a panel up here who will answer all your questions about AI. So this boot camp is not a developer boot camp. It's not a PhD boot camp. It's a boot camp for those who genuinely want to comprehend what AI is, to help them move through an AI world, and in the investment portion, how to invest in AI. If you already know everything about AI, you need to be in the dev boot camp. For the rest of us, this content is what we need to know or build or manage an AI center of excellence. The content is the foundation of current state AI development. It's not a surprise. It's not something that's not known. You can go get this anywhere. It's just all here in one location. If you concentrate, you will leave here being able to talk AI with any AI developer and probably impress or even scare them a bit. And that's our goal, to keep the devs and the PhDs on their toes. So let's get started with part 1. And this is the boring intro history stuff, but we have to go through it. You need this foundation. So AI is just coding. It's not magic. It's not sentient. It's a mimic of humans for now. The goal is to reproduce human intelligence, but with greater speed and access to far more memory. Now, this comes with complications and ethics, and that is an entire boot camp on its own. But we'll cover some of these items a bit later in the presentation. The key to the success of today's AI is that in the 1990s, we realized that precision is vastly overrated. Humans are not generally precise, and neither is nature. The world is a constant, disorganized flow, and it never stops. Also, machines do not comprehend human. They comprehend math. To bridge the gap, abstraction and representation are critical, and we'll chat more about abstraction and representation later in the presentation. So there are currently 2 primary types of AI. There's narrow AI and there's general AI. But there are more. There's cognitive AI and dimensional AI, and I'm sure there's others out there. In the labs today are cognitive AI. That means that's what they're starting to look at now. And you can think of this as understanding deep context. But on the whiteboards of some labs is dimensional AI. And this is pretty well superintelligence. And the reason that they're called dimensional AI is because they understand far more dimensions than humans do. So their cognition is dimensionally greater than just our simple cognition. Now, narrow AI is a single task or goal-oriented AI. General AI is imprecise and dimensional and can process different stimuli that it might not know. Or it thinks in multiple simplistic dimensions, while we humans think in complex dimension. Narrow AI understands a word or a group of words. General AI responds to any sensory prompt or stimuli with contextual comprehension. So chat AI is an elegant word guessing machine and is just starting to comprehend context and carry context. Now you can think of this, the difference between narrow and general AI, as a kid in elementary school, a young kid. And if you give them a picture of a zebra and ask them to find the zebra in a bunch of pictures, and they do, that's sort of narrow intelligence. They're taking an existing thing and they're looking at it and going, oh, I can find that in this pile, and that's what they're doing. But if you let the kid sort the pictures into groups by context, by themselves, well, now you're starting to move into general intelligence. So they may have a pile of pictures with just zebras in it, or maybe not. That's general intelligence. We are just starting to enter general AI. The key to the next step in AI is context, and both deeper and longer context than current AI systems use, and everyone in advanced AI development knows this, whether they tell you or not. Now, back in the 1950s was the start of computers, but not really. The first electrical generator was 1830. I think it's a Faraday disk, if I'm not mistaken. And shortly after, the electrical switch was created. Computers today are still just formations of binary electrical switches. Even quantum computers are binary quantum state switches. For instance, spin up, spin down, etc., with the addition of superposition and entanglement. So it makes it significantly faster, yet not very persistent. But that's another boot camp. I've already done the presentation on that one. Also in artificial intelligence, we rely heavily on pre-1950s math. Now, AI has been a long, gradual process. In the 1970s through to the 1980s, we entered an AI winter. Until we said goodbye to precision in the late 90s. Now, this was mostly due to fintech, since hedge traders use the same math as AI neural nets today. Today, artificial intelligence is ubiquitous. Phones, businesses, finance, government, it is everywhere, and it's rapidly growing. To achieve this, we replaced precision with weights, or more accurately, probabilities of relevance. This is exactly how we humans move through the world and through life. We are guided with a hierarchy of goals, of which survival is our number one goal. Then we move through life perceiving stimuli and responding to it based on the distance to our goals as measured by the probabilities of outcome. That's our cognition in a nutshell. And you can apply that to anything you do. AI is used wherever an Internet of Things computer chip is used or accessed. If you have a device that connects to the internet or uses an app, then it likely uses or is accessed by an AI somewhere in the world, or at least the data and info that is communicated within that device or held within that device. So what is the difference of AI to previous computer systems? Well, AI is just more computer code and a different way of thinking about learning and decision making in data, i.e. using probabilities and weights. AI is everywhere. We all use it. We are all affected by it, even if we do not know it. It's used when we pick up our phone, when we shop, when we travel, at work, in entertainment. It may not be visible, but it is behind the scenes, and it is growing at an astronomical speed. And it is monitoring us and building our digital clones for corporations, governments, and groups, and it does this every single day, constantly.